Hi, everyone. My name is Behzad, and I'm a postdoc fellow at Stanford University, working with Dr. Tina Hernandez-Bossard and Dr. Catherine Curtin on the generalizability and fairness of AI models in clinical applications. I'm so excited to be here and happy to introduce our study to this great community. The development and external validation of machine learning models for identifying patients at risk of postoperative prolonged opioid use, PORPOISE. In the PORPOISE project, we aim to propose an AI approach to more effectively manage pain after surgery using opioids. Please go to the next slides. As you know, opioid is a powerful analgesic that is often prescribed after surgery to manage pain. Even when prescribed correctly, it can be highly addictive to some, and it can also have serious complications such as dependence and abuse that cause significant morbidity and mortality. The clinical point is that opioid exposure following surgery is a major risk factor for long-term opioid use and abuse. As a result, it must be carefully managed following surgery on patients. Please go to the next. We follow three main goals in the PORPOISE project. The first one is to improve pain management following surgery. The second one is to identify patients at risk of prolonged opioid use prior to prescribing opioid. And finally, we aim to develop and validate machine learning models on different patient groups such as diabetes and depression, and evaluate their generalizability, their discrimination, and calibration abilities on these patient groups. The next slide. In the project, we have a target cohort of patients who have undergone surgery with 8 inclusion criteria and 4 subgroups for evaluation. As a result, we will be able to assess the risk of prolonged opioid use in these subgroups. And the project's outcome is any opioid prescription within 3 and 6 months after surgery. The next slide, please. In the cohort selection, we have used 9 Rx norm opioid ingredients with their descendants, as well as 17 groups of surgeries. All ICD and CPT codes associated with these 17 groups of surgeries have been mapped to OMOP concepts, and these concepts comprise our surgery concept set. Next slide, please. We have characterized our target cohort based on gender, race, ethnicity, age group, and cancer diagnosis over prolonged and non-prolonged opioid users. Next slide, please. We also used odds ratio to assess the top relevant OMOP concepts with respect to prolonged opioid use in cancer condition and procedure domains. And we characterize our target cohort based on these features. For example, in this table, you can see the distribution differences between the prolonged and non-prolonged opioid users over different cancers and over different CDM conditions and procedures. The top that we have determined as a top relevant covariates. The next slide, please. We have used a 6-month observation window in the prediction definition, as you can see in this figure, to predict any opioid drug exposure and opioid prescription indeed between 3 and 6 months after surgery. This is our prediction definition. And next slide, please. For covariate setting, 13 types of CDM covariates have been used in the project from 6 CDM domains, including procedures, conditions, drug, measurement, condition error, and drug error. In one of our experiments, we also evaluated our machine learning models based on top relevant covariates associated with these 6 CDM domains using various feature evaluation metrics such as chi-square, information gain, odds ratio, and PNF metric. In the next slide, we will see the results. Yeah. We published our first results in this year's AMIA symposium, where we validated 5 machine learning models on 2 different feature sets, including, for example, all 58,000 covariates versus 4,000 top relevant ones, as well as 3 different time at risk windows in order to see the effect of the time at risk window on the prediction models, and strict labeling with SNOMED opioid dependence diagnosis code in order to see the effect of the outcome definition. Our single site findings show that the behavior of naive bias is completely different, and while, for example, logistic regression and random forest can achieve the best and the highest sensitivity, the naive bias achieves the highest positive predictive value and a funny score with only, as you can see, 8% of all covariates. The results for all covariates are available in this link, in the link below, and so and you can explore the discrimination and calibration of the models via this link. Please, the next slide. In the rest of the project, we aim to conduct a network study. But what are our objectives in this network study? Actually, first, we want to evaluate the generalizability and the calibration of the machine learning models across multi-site cohort subgroups. Then we want to evaluate the transportability of machine learning models and compare the results based on population differences in the various CDM databases. The third objective is to identify common preoperative risk factors over CDM databases. And finally, we want to improve the generalizability of machine learning models by incorporating different models trained on different populations. And finally, the next slide, please. Therefore, to achieve these goals, we are looking for data partners who have access to CDM databases and any Atlas instance. It's worth noting that we are very open to any feedbacks, any changes and suggestions, so please feel free to make them. In the project, we have used Atlas for cohort study and R for multiple prediction. Therefore, we anticipate from our data partners to run our cohort characterization on the Atlas and run our prediction module in R for internal and external validation purposes. And so we have developed our prediction modules using OHDSI PLP package, and you only need to set up a simple YAML configuration file and run a simple R script without any knowledge of R programming. And so we have explained all the details in the project Git repository, which will be made public soon. At the moment, the Stanford community can access to this repository, but will be public this repository out of Stanford. And so the next slide, please, and finally, I'd like to thank OHDSI for providing such a great community and providing this opportunity for me. And also, I would like to thank Dr. Behzad and Dr. Curtin for supporting me in this project. And thank you all for your attention. And please feel free to contact me, Dr. Behzad or Dr. Curtin, if you have any questions or wish to join the PORPOISE project. We will be happy to have you involved in the PORPOISE project. Thank you all. That's all.